Good afternoon, dear students. Audio, video clear na? Please give reply. Write this question. Find I naught of the network shown. Find I naught of the network shown. Find I naught of the network shown. Draw this figure. Arpit Dev, yes, you can continue. Arpit Dev, you can continue. For this particular example, how the 2, 3, 6, how the 2, 3, 6 are connected in the delta. How this 3, 3, 6 are connected star. 3, 3, 6 are connected in the star. How this 3, 3, 3 are connected delta. How this 3, 3, 3 are connected delta. Can you convert delta to equivalent star? Can you convert delta to equivalent star? Yesterday we had taken one statement. Resistors of equal values transformed from delta to star. Resistance of equal values transformed from delta to star. Resistance value decreased by 3 times. Decreased by 3 times. I hope all of you remember that one. Yesterday we concluded. Resistance of equal values transformed from delta to star. Resistance value decreased by 3 times. Can you redraw this figure? We converted delta to equivalent star. Delta to equivalent star. Then for this example, what is the total resistance of this one? Is the 3. Total resistance 3. But resistance entire branch is the 7. How this 3 and 7 both are connected parallel? How the parallel combination connects in the series? This parallel combination connects in the series. Can you find out the equivalent resistance? This equivalent resistance is the, what will it is with the 1? What is this one is the 7. 7 and 3 both are connected to the parallel. 7 and 3 both are connected to the parallel. If you simplify this one, then what about this equivalent is equal to? If you simplify this one, what is the equivalent is equal to? Simplify it. Find the equivalent resistance. What the equivalent is how much? 3.1. 3.1 ohm. From this one, can you find out the total current? Can you find out the total current? Total current equal to, we write this with a Vs by R equivalent. Source voltage is a 10, but the R equivalent is a 3.1. Now, by applying current division technique, can you find out I naught value? What is the total current? How much here? 10 by 3.1 total current into opposite resistor. Now, for this entire branch, what is the opposite resistance? 3 by total resistance. Simplify करो जी, simplify करने से can you find out I naught value? Simplify करो, simplify करने से can you find out I naught value? Check करो, many students are saying 0.96. Is it correct? Check करो जी एक बार. .96, very good. Very good, very good. That is one. Find Z1. Find Z1 of the network shown. Find Z1 of the network shown. In this example here inductive reactance is given. Carefully observe. Here inductance not given, inductive reactance is given. About the J again we discuss very clearly in the steady state AC circuits. For this example here capacitive reactance is given. Inductive reactance, capacitive reactance is given. What is the unit for this one also? Reactance also ohms. That's why the procedure what we applied for resistance, the same logic you can go for reactance also. The procedure what we apply for the resistance, same logic we can apply for the reactance also. Then to find out Z1, simply can you write this product of adjacent sides. For this example, what are the adjacent sides? J3 and the minus J3 by total impedance. By total impedance. Can you cancel these two terms? If you simplify this one, what is Z1 equal to minus J3? Z1 equal to minus J3. In the options, what they do here, they may ask the nature of element also. Every time remember as a, this pledge is correspond inductor, pledge J correspond inductor, minus J correspond capacitor, minus J correspond capacitor. About this one, again we discuss very clearly in the steady state AC circuits. Capacitor. Somebody requested in the previous slide. Copy कर लो जी. Okay. Next put side heading source transformation. Okay, copy कर लो this one. Okay. Next put side heading source transformation. Next put side heading source transformation. In the practical system, only independent voltage sources exist. In the practical system, only independent voltage sources exist. No independent current sources exist. I hope all of you remember this point. Now, from this concept only, source transformation technique is developed. According to source transformation, voltage source can be replaced by equivalent current source. Voltage source replaced by equivalent current source. Or the current source replaced by its equivalent voltage source. Current source replaced by its equivalent voltage source. In this example, by knowing the source voltage, internal resistance, can you find out the source current? Can you find out the respect to this source current? To find out the source current, simply we can write this with the Vs by Rs. That source current only is named as a short circuit current. That source current only named as a short circuit current. Short circuit current Is. Here the assumption is that every time internal resistance the voltage source and current source both are exactly equal. Internal resistance the voltage source and current source both are exactly equal. To avoid confusion, I am writing like this. Internal resistance correspond to voltage source. Internal resistance correspond current source. Every time magnitude of internal resistance the voltage source and the current source both are exactly equal. Only to avoid a confusion, I am indicating like this. Internal resistance correspond to voltage source and correspond to current source, both are exactly equal. Both are exactly equal. And by knowing the current source and internal resistance, we can find out the source voltage. To find out the source voltage, what is our requirement is the open circuit voltage. Shall I say this entire current goes to this RS. In this example, entire current go to RS. Then voltage across this one, voltage across this one, both are the same. In this example, voltage across this one, voltage across this one, voltage across this one, both are the same. We can write this VOC is equal to ISRS. Open circuit voltage. That open circuit voltage only is named as a source voltage. Yes, Goyal. Actually, in that problem, what you are doing here, we are taking the reactances, not capacitance. Melu John, just I am explaining the source transformation. No figure is available here. In this page, I am explaining the only source transformation. Okay, Goyal, we are not using capacitance in the previous problem. We are using reactance. Whenever the inductor capacitor combinations are given, we have to do the problem with respect to reactance. Now open the workbook, read the question number 18. In the workbook, read the question number 18. For this example, the 5 ohms is the internal resistance of this one. The 4 ohms is the internal resistance of this one. What about the 10 ohms is the external resistance? 10 ohms is the external resistance, or we can also call it as a load resistance. We can also name it as a load resistance. In this example, to solve the problem, we can go for so many methods. But here simply I am going for the source transformation. For this example, current source replaced by its equivalent voltage source. Current source replaced by its equivalent voltage source. Can you convert each current source into respect to voltage sources? Convert each current source into respect to voltage source. 4 and 5 means what is the voltage, how much? 20. 4 and 5, what is the voltage, how much? 20. 10 ohms. 5 ohms and the 4 ohms. I converted each current source into respect to voltage source. Now from this one, shall I select this, sir? The current of this branch equal to 0. For this one here, plus, similar polarities means subtraction. 20 minus 20, what is the potential difference equal to 0? If potential difference equal to 0, then what is respect to current equal to 0? Here the current in the 10 ohm resistance equal to 0. In this example, current in the 10 ohm resistance equal to 0. Now current in the 10 ohm resistance 0, thereby here this entire 4 ampere current goes to 5 ohms. This entire 5 ampere current goes to 4 ohm resistor. This entire 4 ampere go to this one, this entire current go to the 4 ohm resistor. The answer what you got here, that current we are indicating the original figure. here क्या बोल सकते हैं, no source is contributing current, no source contributing current to the external resistance. Thereby this entire current go to its own internal resistance. In the question what is asking the power in the 5 ohm resistor. The question what is asking the power in the 5 ohm resistor. Now what is the current, how much here, 4 square into 5. Then what is the power equal to how much, 80 watts. What is the power equal to 80 watts. And here you get one more doubt also. You will get doubt as a current in the 10 ohm 0. Thereby current in the 5 ohms also 0. Current 10 ohm 0, thereby current in 5 ohms also 0. Thereby the power equal to 0. We should not apply that logic here. Reason is 5 ohms is the internal resistance of the source. 4 ohms is the internal resistance of the source. 10 ohms is the external resistance, or we also name as a load resistance. Our source transformation technique is applied only to find out response in the load, but not in the internal resistance. We are applying source transformation means its purpose is only to find out response of the load, but not in the internal resistance. Write the note here. Write the note. Write the note here. Source transformation is applied. Source transformation is applied only to find. Source transformation is applied only to find response in the. Only to find response in the load resistor. Response in the load resistor, but not in the internal resistance. But not in the internal resistance. But not in the internal resistance. Read the question number 51. क्वेश्चन पढ़ो जी एक बार. Read the question number 51. We can solve this problem by using so many methods, but here I am trying to solve only by using source transformation. You can go for so many methods. Now in this one, step by step manner, let us simplify the network by using source transformation. For this example, first can you convert this current source into equivalent voltage source? What about this one? How the 6 and 3 both are connected in the parallel? 6 and 3 both are in the parallel. Can you convert this current source into equivalent voltage source? In this example, can you convert this current source? Can you convert a current source into equivalent voltage source? And how the 6 and 3, in this example, how the 6 and 3 both are connected parallel. 6 and 3 both are connected parallel. What is the equivalent is equal to 2? Equivalent is equal to 2. Let us simplify further. For this example, can you convert this current source into equivalent voltage source? Can you convert the current source into equivalent voltage source? And come to this branch. Come to this entire branch. Now for this entire branch, देखो जी प्लस प्लस सिमिलर polarities अभी आपको इन द फर्स्ट क्लास में डिस्कस किया था. Similar polarities means what do you write the subtraction. Then how the 16 and 20 both are connected in the series. 16, 20 both are in series. What is the net voltage? How much? 48. 16. Net voltage is 48 and 20 and 16 both are in series, 36. Can you convert this current source? Into equivalent voltage source? Convert the current source into equivalent voltage source. What is the voltage? How much here? 12. Here the 12 into 6. What is the voltage? How much here? 72. Now correspond this arrow mark. Give the positive sign. Other one is a negative sign. Whenever you are applying source transformation, concentrate on the current directions carefully. According to current direction, correspond arrow mark, give the positive sign. Other one is a negative sign. Come to next point. Again, can you convert this voltage source? Can you convert the voltage source into equivalent current source? In this example, can you convert the voltage source into equivalent current source? Hmm. 16 or 26, okay, sorry, this is a 26, no? 36. Okay, in this example, previously 48, what about 20 and 16? 20, 16 both are in the series. Equivalent resistance is 36. What about this other voltage source? Try to convert this voltage source into equivalent current source. Convert the voltage source into equivalent current source. Can you simplify this one? How the 36 and 12, both are connected in the parallel. In this example, this 36 and 12 both are connected in the parallel. 36, 12 both are in the parallel. What are the equivalent resistances for this one? In this example, what are the equivalent resistances for this one is check out. I think it is a 9 ohms. Verify the answer. Okay. Now 9 ohms and this current source. Can you convert this one to equivalent voltage source? देखिए ये दोनों के लिए equivalent is कितना है 9. 9 and current source. Can you convert this one to equivalent voltage source? If you convert this to equivalent voltage source, check करो जी, what is the voltage will be 12. Yes. I value. Try to convert this current source into equivalent voltage source. Convert this one to equivalent voltage source. Finally, we got network like this. Now for this one, can you write a KVL equation? For this one, can you write the respective KVL equation? Check करो जी. Lower potential to higher potential by KVL. By KVL, lower potential to higher potential voltage rise. What about this one? This I current circulates in the 9, 12 and 7. I current circulates 9, 12 and 7. What is the total resistance for this one? In this example, what is the total resistance in the 19 and 28? 28I. And in this example again, lower potential to higher potential voltage rise. Lower potential, higher potential voltage rise. Here also again, lower potential to higher potential voltage rise. What is the same? No? Now this entire equation is equated to 0. Entire equation equated to 0. In the data itself, current value is given. In the data itself, current value is given. But current value how much here? 5 amperes. In the question itself, current value is given. But current equal to 5 amperes. By simplifying this one, can you find Vs value? Substitute I equal to 5 amperes. Simplified, find the Vs value. Simplify करो जी. Dear students, for this problem we can go over so many methods, but here आपको to get the idea, I am trying to solve the problem step by step manner only by using source transformation. Check करो जी. Now many students are saying 56. Check करो, is it correct? Check करो एक बार. $56. Oh, somebody got 156. Check कर लो जी एक बार. That is one. Find current in the ideal diode. Find current in the ideal diode of the network shown. Current in the ideal diode of the network shown. For this example, can you transform this voltage source into equivalent current source? Here also you can go for so many methods, but I am solving with help of the source transformation. What is the requirement? Current in the ideal diode. Current in the ideal diode. Can you convert the current source into equivalent voltage source? Can you convert this current source into equivalent voltage source? Ten by four means what a current? How much here? 2.5 amperes. Convert this current source into equivalent voltage source. But resistance how much? 1. But the voltage is 2. Convert this current source into equivalent voltage source. Now correspond arrow mark give the positive sign, and other one is a negative sign. What is the current? How much here? 3 amperes. In this example, how the 2.5 and 3 amperes, 2.5, 3 amperes both are in the same direction. 2.5 and 3 both are in the same direction. Same direction means what is the net current for this one? 5.5. Net current is a 5.5. What about this one? How the 4 ohms and 4 ohms both are connected parallel. 4 ohms both are in the parallel. What is the equivalent is equal to how much? 2 ohms. What is the equivalent is how much here? 2 ohms. 2.5 and 3. Shall I indicate this here? Current source 5.5. 4 and 4 both are in the parallel. What is the equivalent resistance? 2. Can you convert this current source into equivalent voltage source? Convert this current source into equivalent voltage source. If you convert this into equivalent voltage source, what is the voltage value? How much? 11. Check karo ji, can I write this? We converted this current source into equivalent voltage source. Can you do the calculations now? What is the requirement current in the ideal diode? कौन है? खुशी शर्मा. Anywhere you can connect. किधर भी कनेक्ट कर सकते हैं जी. शर्मा जी. खुशी शर्मा किधर भी कनेक्ट कर सकते हैं. No issue. Here also, dear student, don't get confusion. Don't think as a resistance should means always current positive. इधर करंट नहीं करना है. ऐसा कुछ भी नहीं है जी. किधर भी कनेक्ट कर सकते हो. वो आपका चॉइस. But generally, in the many cases, what we do in representation, it is connected to positive. क्यों? मतलब करंट कैसे जाते हैं? हाइयर पोटेंशियल टू लोअर पोटेंशियल. आप इधर भी कनेक्ट कर सकते हैं. इधर रेजिस्टेंस हटा दो, कनेक्टेड सीरीज टू नेगेटिव टर्मिनल. आंसर विल नॉट चेंज. आंसर नहीं बदलते. देन फॉर दिस एग्जांपल क्या चाहिए जी आपको? करंट. व्हाट इज योर रिक्वायरमेंट? इज द करंट. In this example, I equal to this plus subtraction. What about this for ideal diode? For ideal diode, what is the forward bias resistance equal to 0? For ideal diode, forward bias resistance equal to 0. आप इधर simplify करें तो then what is the I equal to how much? 3 amperes. आप इधर simplify करें तो what is the I equal to how much? 3 amperes. Okay. बोथ करंट्स इन सेम डायरेक्शन. अजय सिंह क्या एब्सेंट है क्या आप? बोथ करंट्स आर इन सेम डायरेक्शन. दोनों करंट सेम डायरेक्शन तो क्या करते हैं? एडिशन. भूल गए क्या? फर्स्ट क्लास में डिस्कस किया है जी अजय जी. दोनों करंट सेम डायरेक्शन बोल तो यू कैन डू द एडिशन. रिवीजन नहीं हो रहा है. यू आर आस्किंग बेसिक क्वेश्चंस. ओके. Right, the next question. Find current in the 5 ohm resistance. Find current in the 5 ohm resistance. Current in the 5 ohm resistance. current in the 5 ohm resistance. Okay. Now for this example, now for this particular example here, they give either this one independent voltage source, independent current source, independent voltage source, independent current source, and this is the dependent current source. Source transformation technique can be applied for the independent sources as well as for the dependent sources. Our source transformation technique can be applied for the independent sources as well as for the dependent sources. But here remember, as a whenever you are applying for source transformation for dependent source, wherever the dependent source magnitude depends, okay, in this example its magnitude depends on the voltage of 3 ohm resistance. Wherever the dependent source magnitude depends without disturbing that element, wherever the dependent source magnitude depends, in this example its magnitude depends on the voltage of 3 ohm resistance. Wherever dependent source magnitude depends without disturbing that element, transformation can be applied. Without disturbing the element, transformation can be applied. That means here in this example, suppose if you apply transformation for this one, what do we get? Voltage source transformed into equivalent current source. If you transform this one equivalent current source, voltage of 3 ohm resistance changes. When the voltage of 3 ohm resistance changes, the voltage of this 3 ohm resistance changes. Thereby this dependent source value also changes. If voltage of 3 ohm resistance changes, this dependent source value also changes. That's why here wherever the dependent source magnitude depends, without disturbing that element. In this example, its magnitude depends on the voltage of 3 ohm resistor. We should not disturb this one. Without disturbing this one, for remaining sources, transformation can be applied. Write one note. Okay, I hope all of you clear this one. A example में you cannot apply any transformation for this voltage source. क्यों बोलते? Dependent source is depends on the voltage of 3 ohm resistance. Okay, except this one, for remaining sources के लिए आप transformation apply कर सकते. Add the note. While applying source transformation, somebody asked in the previous slide. Copy कर लो जी. Write the note. While applying source transformation, for dependent source wherever wherever dependent source magnitude depends, wherever dependent source magnitude depends, wherever dependent source magnitude depends, without disturbing that element, without disturbing that element, transformation can be applied. Without disturbing that element, transformation can be applied. Transformation can be applied. Okay. Then here in this example, we should not apply any transformation for this voltage source. We should not apply any transformation for this voltage source. Can you convert the current source into equivalent voltage source? Can you convert the current source into equivalent voltage source? What do you write the 1.5 into 2? 1.5 into, what is the voltage? How much? 3 volts. What is the voltage? 3 volts. Now corresponding arrow mark give the positive sign, and other one is the negative sign. Now what is the resistance value? How much here? 2. Resistance is 2. Can you convert this dependent source? Can you convert this dependent current source also into voltage source? If you multiply these two, what is the voltage value? How much? 2Vx. Voltage is 2Vx. Now corresponding arrow mark give the positive sign, and other one is the negative sign. For this example, what is the resistance? How much here? 4. Resistance is 4. But resistance of this one is 5. We converted each current source into respective voltage sources. We converted each current source into respective voltage sources. Can you write the respective KVL equation for this one? Can you write the respective KVL equation for this one? If you write the KVL equation for this one by KVL, lower potential to higher potential, voltage rise. Voltage rise. In this example, the loop current, this one, let us assume as a I. Loop current, let us assume as a I. Here this I current circulates 3, 2, 4 and the 5. Can you add all the respective resistance values? Can you add all the respective resistance values? 3, 2, 5, 5, 5. That means what is the total resistance? How much? 14. Total resistance is 14I. Can you add all the respective resistance values? Again here lower potential to higher potential, voltage rise. -3. Now higher potential to lower potential, voltage drop. This entire equation is equated to 0. This entire equation equated to 0. How many unknowns are there in this equation? 2 unknowns. One is the Vx, other one is the I. What is the Vx, other one is the I. Here the Vx is the voltage of 3 ohm resistance. Vx is the voltage of 3 ohm resistance. In the 3 ohm resistance, how much current circulating? I. Check करो जी. Now can you substitute this equation 2? जो equation 2 है ना, can you substitute the equation 2 in equation 1? Substitute कर सकते ना? Check करो जी, do it. Substitute this equation 2 in equation 1. Substitute equation 2 in equation 1. चेक करो जी. Substitute करके simplify करने से I वैल्यू निकाल सकते ना आप? Try करो. चेक करो. Many students are saying 1.15. simplify it, simplify करो, I equal 1.15. कौन है यादव? We are including polarity also here. देखिए यादव, current is entering at positive terminal. When current enters at positive terminal, sign for the current is taken as a positive. By including polarity only, we wrote equation. Okay, Yadav? Okay, very good, very good. Oh, somebody got 1 ampere. Check कर लो जी एक बार. Many students are saying 1.15. Check कर लो एक बार. Next, put side heading mesh analysis. Next, put side heading mesh analysis. Oh, Bhavana, you got 2.25. Correct answer क्या है जी? Many students are saying 1.15. Agarwal, you got 0.25. Check कर लो जी एक बार. Okay, next put side heading mesh analysis. Okay. Next, let us go to mesh analysis. Now, for this particular example, can you conclude how many loops are present in this network? How many loops are there in this network? For this particular example, how many loops are there present? चलो check करेंगे. Now, for this example here, देखिए इधर loop 1, loop 2, loop 3, loop 4. देखिए इधर loop 5, loop 6, loop 7, loop 8, loop 9. How many loops? So far how many loops you got? 9. देखिए is a loop 10, loop 10. Likewise, so many number of loops are present. Likewise, so many number of loops are present. But in this example, our main focus on the mesh. What is our topic name is a mesh analysis. Our topic name is a mesh analysis. Then let us see what is the difference between the loop and the mesh. Here the mesh is a loop, it does not consist of any inner loop. Here the mesh is a loop, it does not consist of any inner loop. Then with respect to definition, here, shall I say this here? Now it is a mesh 1. Mesh is a loop, it does not consist of any inner loop, mesh 1. It is a mesh 2. It is a mesh 3. It is a mesh 4. Mesh is a loop, it does not consist of any inner loop. It does not consist of any inner loop. Now, how many meshes are present in this example? 4 meshes. Can I select this in this example? Every mesh can be called as a loop. Every mesh can be called as a loop. But every loop cannot be called as a mesh. But every loop cannot be called as a mesh. Come to the next point. Now, this mesh analysis is having one limitation. This mesh analysis is valid only correspond to planar networks. Mesh analysis is valid only correspond to planar networks. Meaning of planar network is when the network is drawn on plane. Meaning of this planar network is when the network is drawn on plane without any crossover. See, this symbol indicates the crossover. Crossover meaning no connection is exist. A crossover meaning no connection exists. When the network is drawn on plane without any crossover, then we can now this as a planar network. Then it is known as a planar network. देखिए in this particular example here no crossovers are the exist. For this particular example, no crossovers are the exist. We can name this as a planar network. Now for this example here, देखिए इधर crossovers exist. Now give the reply, is it planar, non-planar? Give the reply, is it planar, non-planar? Okay. Here you have to observe as a, even though crossovers exist, check करो जी, the same figure we can draw like this. Check करो, the same figure we can draw like this. In this example, this connection indicated outside of this one. Even though crossover exists, we can redraw this network without any crossover. Even though crossover is there, it is possible to redraw the network without any crossover. We can redraw this network without any crossover. That means again it is also named as a planar network. Even though crossover is there, if it is possible to redraw the network without any crossover, we can name as a planar network. Come to this one. But in this example, it is not possible. It is not possible to redraw this network without any crossover. It is not possible to redraw this network without any crossover. Here, every time the crossovers exist. That's why here it is an example for the non-planar network. But if you come to second one here, even though crossovers exist, we can redraw this network. We can redraw this one without any crossover. That's why it is also planar network. फिगर्स कॉपी कर लो जी, तीनों फिगर्स कॉपी कर लो. देखिए, एग्जाम्पल फॉर प्लेनार नेटवर्क, इट इज अ थर्ड वन इज अ नॉन प्लेनार नेटवर्क. इट इज द नॉन प्लेनार नेटवर्क. Okay. Next, for citing procedure of mesh analysis. Next, for citing procedure of mesh analysis. Next, for citing procedure of mesh analysis. Now, to explain the procedure, let us take one simple example. To explain the procedure, let us see the one simple example. देखिए इधर in the mesh analysis पहले क्या करना है बोले तो identify total number of meshes in the given network. Identify total number of meshes in the given network. देखिए example में total how many meshes are there? How many meshes? 2 meshes. The first point is the identify total number of meshes in the given network. देखिए example में how many meshes are there? 2 meshes. Then after assign the current direction. Assign the current direction. Assign the current direction for each mesh. In this example, I am assuming as a both currents in the clockwise direction. Assign the current direction. You can go for any direction. Generally, in the objective questions, what they do, in the question itself, they specify the current direction. Question में आपको define कर देते directions. You can go for any direction, but finally magnitude is remains same. We get difference only in the sign. If you come to objective questions point of view, in the question itself they define the current direction. कभी भी डायरेक्शन मेंशन किया तो वही डायरेक्शन में आप केवीएल इक्वेशन लिखना है. आप डायरेक्शन चेंज करें तो विल गेट द सेम मैग्नीट्यूड ऑफ करंट मगर साइन बदलते. In this example, I am assuming both currents in the clockwise direction. Next one. Now here the develop KVL equation. Develop KVL equation for each mesh. Develop KVL equation for each mesh. Now in this example, now let's write the KVL equations. Let's write the KVL equations. Here the lower potential to higher potential. Lower potential to higher potential voltage rise. In this example, I1 current circulates 2 and 3. I1 current circulates 2 and 3. But the total resistance how much? 5. 2 and 3, 5. देखिए come to 3 ohm resistance. For 3 ohm resistance, I1 downwards. 3 ohms के लिए I1 downwards. But the I2 is upwards. 3 ohms के लिए I1 downwards, I2 is upwards. Opposite direction. Opposite direction. What do you write the sign? Minus. Now we got the equation 1. You got the equation 1. Now come to loop 2. Now correspond loop 2, I2 is acting downwards. For this example, देखिए इधर I2 is acting downwards. मगर 2 ampere is acting upwards. I2 कैसे जा रहे? Downwards. 2 ampere से upwards. दोनों कैसे जा रहे? Opposite direction. Opposite means what will it is? This I2 is equal to -2. I2 equal to -2. क्वेश्चन में कभी भी करंट सोर्स दिया तो इक्वेशन डेवलप करने का जरूरत नहीं है. Whenever the current source is given, no need to develop any equation. No need to develop any equation. For this example, I2 is the downwards, मगर 2 amperes is the upwards. 2 amperes upwards. Opposite direction. -2. Now fourth point is by solving equations, find out the loop currents. Find out the loop currents. Then here by substituting equation 2 in equation 1, can you find out I1 value also? First write the steps लिखो जी पहले. Write the first point. Identify. First point. Identify total number of meshes. Any problem in the audio? Dear students, any problem in the audio?